Good evening to all. In this video, we are going to discuss about case study on combinational logic circuits in digital logic systems. And especially for this digital logic system, we are using for combinational logic circuits. The combinational logic system nothing but it is having a adder and a subtractor and magnitude comparators. So like this, all those devices has been added for this combinational logic circuits. Especially for this digital locking system, we are using this combination circuit for zeros on one logic purpose because the locking system is having on and off conditions, so that we are in need of these logic combination circuits are very useful to identify the locking systems. And most probably, we are using encryption and decryption methods will be useful for this logic system to enhance the model. So let me see how this digital locking system has been framed and it will be working in the combination of the series.
So when we were talking problem statement matter, so what is difference between lock and digital lock? Lock we need a physical key or something. But digital lock we can memorize with a set of books, combination rules. So in a combination rules, it's not easily manipulated. If we have a key, we can duplicate it, but we can't duplicate a combination code because every combination has a unique rules. So we can take the example of Bitcoin. There are millions of Bitcoins around the world, but every Bitcoin has a unique number.
So based on the encryption, we have to identify which kind of Bitcoin is this.
Millions of Bitcoins, but they can't duplicate it because it has unique combinational codes. If we copy it, they can find it easily. So it's a very secure. So like that, it's very easy and reliable and very secure. This is what we are using this combination.
So I'm going to share about the applications of the digital log system in this existing year. So first is bank ATMs. So we can't able to withdraw or deposit the amount without typing the PIN as well as passwords, etc. So the next is defense sector. In defense sector means many of the higher officials of military people store their ammunition as well as highly confidential records in storage room. So in order to get away from the enemies such as terrorists and etc. So the next is smart automation. Smart automation means from the existing traditional keys, so we can upgrade to the digital key means that no thieves can enter our house without the passcode.
So let's come into the requirements to create this lock system. So first we will know there are two passcodes we can use. One is 4-digit passcode and 6-digit passcode. So we can use here 4 push buttons. Like we can differentiate the push buttons like A, B, C, and D. So we will perform a certain logic combination circuit which will be open for that combination. So if we use 4 and 6 bits. So if I am setting a combination with logic like if A is set as high and B is low, and C is high and D is low.
So it's a default model for every type of combination.
We can also consider that according to the need of our requirement. So the next one would be when the certain combination circuit is entered by the user. So it will generate an output signal to the relay which controllable device we are using. So it will trigger the relay and it can unlock the mechanical part of that lock. Let me explain some logic, some of the Boolean expressions or logics to perform this operation. So if I set A, B, C, D, and R as low, so for this combination logic, it will generate the output signal and it will match with the signals which will be present in the controllable device. So if it does not match, it will not unlock the lock. So for the certain combinations we use. So it will be easily replaceable, configurable without replacing the circuit. Because if someone is noticing you or watching unauthorized person, person is watching you. So if he or she watches the combination we are using. So it will become confidential now for you. So if we continuously or periodically we will change the combination, so it will not be identifiable by anyone. So it will be a safer one for the user.
So let's discuss about the innovators. It is low cost uses the minimal hardware
Because
components.
each case having a less amount money, so that we are using IC for combinations.
Then it works only the one combination of the inputs. Then we can with that instead of unblocking, we can correct the inputs of the unblocking system. Then it reduces the wear and pressures. Then it can combines with the expanded logic of the combination.
So let me add one point. I just need to say that flow of the circuit logic. So if I'm taking the combination like A is high and B is low or zero and C is high and D is zero or E is zero. So the circuit flow will be like if A and B will be passed through the inverter gates. So it will be get inverted. So the flow will be the inverted 4 inputs will be given to the 4 input NAND gate. So it will reduce the complexity of the circuit. So it can easily fix in a simple and small locking systems. So this is the context.
So I'm going to be conclude this one. So the case study highlights how the combination logic circuit is defined in the digital log systems. So in this, the combination systems are involved, how it is cost efficient and reliable, and how it is
Secure.
adaptable and securable. So these are it included, and this is all mainly used in the IoT based monitorings and remote accesses. So this combination logic circuits are involved in Boolean expressions like what we said in A to B. So these and all we conclude this.
So it is a simple circuit so that the user can make it as a very easy to know the concept.
Yes.
So that it will be very easy for others. So thank you all.
Thank you.